Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question 23 on our Fermat paper. Let Tn equal the integer closest to root n. For example, T1 and T2 are 1, since the square root of 1 is 1, and the square root of 2 is 1.4, so you round down to 1. But T3 is 2, since root 3 is about 1.73, and you would round that up. I'm going to go out on a limb here and say this question probably will require me at least to use my calculator unless I know things like the square root of 67 off the top of my head. I'll try and avoid it if I can, but if I have to, so be it, just to understand the rounding. So what do we want? We want the sum of 1 over T1 plus 1 over T2 plus 1 over T3 all the way up to 1 over T 2010, the year of the contest, and we just want to know what does that equal to. Okay, well, it's going to be a nice fraction, or, might even be an integer if e is the right answer. I don't know. But it will be a fraction because the T1s, the Tn's are all integers, so not too much of a problem. All right, so we know the sum is going to sort of start out 1 over 1 and then 1 over 1. They tell us the first two are 1, and then it goes to 3. And then 1 over, this would be T4, that's going to be 2 because the square root of 4 is 2. Now the square root of 5 is closest to 2. Same with, I believe, 6. I'm going to bust out the calculator right now, but I'm pretty sure it's 6. 2.44. But I think when you hit 7, you go to 1/3. Square root 7, 2.64, so it goes to 1/3. And it's going to be 1/3 for 8, and the 9, and the 10. And so what we get is some 1s, some 2s, some amount of, ones, some halves, some amount of thirds. And if I knew how many thirds, if I could figure out how many numbers have their square root close to 3, if I could figure it out for 2, if I could pick any number and say, well, how many numbers have their square root that's closest to 15? Then I might find a sort of a speedy way of adding this up. Okay. One thing else to note, here we get 2, a half, a half, a half, a half. That adds up to 2. I might even bet that we get third, might get 6/3, in which case that's 2 as well. In fact, we could double check that right now. 7, 8, 9, 10, 11, 12. So I'm saying the square root of 12 is close to 3. Grabbing my calculator and checking that out. Yeah, 3.4, but the square root of 13 should be too far away. Yep, 3.6. So we can start noticing patterns like that. Now, just because it works for a small amount, that we get 2, 2, 2, doesn't mean that it necessarily always will. Now, if you're confident in that, and especially if you notice maybe you're running out of time, then go with the pattern. I'm fairly confident it'll probably just be 2, 2, 2, 2. I'm going to explore it a bit more, because I obviously have the time for that. But where would we go from there? Okay, well, it'll be 2, 2, 2, 2. And then you start getting things like the square root of 2010, which I don't know off the top of my head. So it's closest to 45. And so it's not the last one that's closest to 45, certainly. But there'll be some that are close to 45. And so you'll get 2, 2, 2, 2, 2, all the way up to, you'll get 88 1 over 44s, and that adds up to 2. And then you'll just get some number of 1 over 45s, and that's what you really need to work out. Okay, I suspect that the 2 pattern will continue, but let's explore it for a little bit. Now, I have been reaching for my calculator. You don't actually need to. How would I know if root n is closest to m? Right? How would I know this? Well, n here is an integer, and if it's closest to m, then root n would need to be less than m plus a half, but greater than m minus a half. Otherwise, it'd be closer to m minus 1 or m plus 1 on either side. So this is what we need. And since the m is supposed to be an integer, because we want the closest integer, these are all numbers that look like integer 0.5. Integer 0.5. And this actually gives us a very nice range of numbers. So, for example, if your closest to m is 1, you're looking at square roots that are between 0.5 and 1.5. If you want to be in this 2 range, you're looking at numbers that are between square roots that are between 1.5 and 2.5, because anything bigger would round up to 3. Okay? So how many square roots are in this range? Well, if root n is in this range, then n is in the range of, well, if we just square these, so that'll be 2.25, and 2.5 squared is 6.25. Same thing, if root n is in this range, then it'll be between 0.25 and 2.25. So there's 2 numbers in this range. There's 4 numbers in this range. Okay? And so there's actually a very, very nice little pattern here. Okay? If I've got, let's say, m minus a half, or so let's say m plus a half, m+1/2. So a number that looks like m.5. The square of that follows a very nice pattern. So things like 15, 25. If you don't know this pattern, it's a cute little trick. But the way you figure it out is you take the 5, put it at the end as a 25. And in this case, since we've got a decimal and we're squaring it, the decimal place will have 2 decimals. 2 decimal places, so we'll get a 0.25 at the end here. But then you take whatever is preceding the 5, so 4, 3, 2, or if I wanted to do 105 squared, that would be fine. If all follows the same rule, we just take off the first 10. And you do m times m plus 1. So 45 squared is 4 times 4 plus 1, which is 5, 20, followed by a 25. How about 105 squared? Well, it'll be 10 times 11, 110, followed by a 25. So 10.5 squared would be 110.25. All right. So if I'm talking about m minus 1.5 squared, and n has to be between that and m.5 squared, and if that's true, then Tn is equal to m. Well, how many numbers satisfy this range of values? Well, you'll get m minus 1 times m, 0.25, and you'll get m times m plus 1, followed by a 0.25. Now, how many numbers are in this range? Well, the 0.25s don't really make a difference. How many numbers are in here? Well, this number minus this number. You're going to get the 0.25s cancel out. The m will factor out, and you'll get m plus 1 minus m minus 1, which will end up being m times 2, or 2m numbers. And this is exactly why the pattern that we sort of noticed will work out. Now, it's not a written contest. This is a multiple choice contest. So as soon as you notice a pattern, if you are confident in the pattern, you go with it. Okay? So question 23 would not nearly be taking as much time as I am devoting to it. I am taking the time to explore and also explain, why does the pattern actually work out? Assuming that I'm being clear and you're following along the explanation. But there are 2m n's that have Tn is 1 over m. So the sum of the 1 over Tn, 1 over Tn plus 1, all of these ones, there's going to be 2m of them. And that's a sum of 2. Great. So we have proven, although we don't never need to on a multiple choice contest, that the pattern works. And this just makes me a bit more comfortable. It gives me a little bit of peace of mind. Okay? So, when it comes to the ones, I know that'll add up to 2. It comes to the halves, I know there'll be 4 of them, and that adds up to 2. But I know this pattern will continue on. And so we'll get a 2 for the 1s, for the 2s, for the 3s, all the way up to the biggest square root that we can find. And I've already sort of broken down what exactly we'd be doing, but up to, what is it? 44 squared plus 44. So I think it goes up to 190. So 1980. Just trying to be technically accurate. Yeah, so these all work out, and then you'll get what do we have? 44 squared minus 44 T1892. So there'll be 88 of these, and there'll be 1 over 44s. Oh, sorry, it's 1893. I was wondering, because I said there are 88 of them, but there's not 88 numbers. There was 89 numbers, so I was trying to fill it in. Okay, so that gives me, 44s, 1, 2, 3, all the way up to 44, so that gives me 2 times 44, or 44 twos. So already I'm at a sum of 88, and then I'm going to have a bunch of 1 over 45s. How many? Well, that's what I need to figure out. So the sum is 88 plus some 1 over 45s. And where do these 1 over 45s start? 181, 1981, then T1982. My speaking and my writing is off today. T1982, and this goes all the way up to our cutoff point, T2010, because that's still a 1 over 45, but it's not the last one. So how many of these are there? So these are all 1 over 45s. How many have I got? Well, 2010 minus the one we start with, 1981, and then you add 1 because you've missed a number. So there's 30 of them. So the final sum is 88 plus 30 1/45ths, and dividing by 15 on top and bottom there, you get 2/3, so 88 and 2/3. So that should be our final answer. 88 and 2/3, right there in the middle, it's C, and that's what we would bubble in. We probably would have gotten that quite a while ago, but I did want to, I was curious, and I wanted to justify that you do get groups of 2 each time, and I like that. That's a cute little pattern. Okay, but you didn't need to prove it. You didn't need to take the detour I did. As soon as you noticed, 2s, 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 say, okay, we'll have 44 groups of 1 over t plus 1 over t that become 2. So we'll have 44 2s, and then how much is left over. So it actually would be a very, very quick question if you noticed the pattern. Okay? But I wanted to explore it, as I've said. Up next will be question number 24. We are almost done our 2010 Fermat paper, so feel free to try that question before joining me in the next video for that. Until then, take care.